Guys, we finished. This is all about making ourselves credible in your eyes again, and we're going to do that by admitting how the atom is alive.
We're not going to just stand here and present some egghead scientific argument based on outdated textbooks. I'm just a regular student. I study, they take notes, sometimes miss her class too, but that's fine, right, Megan?
She's got a point.
This uneducated, non-chem major student is trying to assassinate my character, and I can't change her mind. We won't change our mind because we don't have to. We're Hopkins applied chem students. We won't change our minds on anything regardless of the facts that are set before us. We've dug in and we won't change.
Look, you're wasting my time. I obviously know what an atom is.
And why is that?
Because an atom is just a nucleus and electrons, right? How hard is it to model an atom?
I'm glad you brought that up, because, Luiza, science is a liar sometimes.
Oh, God.
This is the first theory of an atom, created by Dalton. He postulated 3 things. 1, elements are made of atoms. 2, all atoms of the same element are identical, and different elements have different types of atoms. And 3, atoms cannot be created or destroyed. Dalton believed he was so smart. He laid the groundwork explaining the definition of what an atom really is. But then another scientist named Thomson came along and disproved Dalton's 3rd point, making Dalton look like a bitch.
JHU Thomson then thought that atoms were made of subatomic particles. He called it the plum pudding model. Negatively charged electrons were scattered throughout the positively charged cloud that formed an atom. However, another scientist named Rutherford performed a gold foil experiment and discovered the presence of a tiny dense nucleus. Therefore, J.J. Thomson was also wrong, making Dalton and him look like a bitch again.
Rutherford's experiment involved firing alpha particles through a thin sheet of gold foil. While most particles passed through with little deflection, some particles deflected at large angles. He then thought the atom had a tiny, dense nucleus. But what about the negative charges? Do they just float around the space outside the nucleus? According to Bohr's model, electrons didn't just randomly occupy space outside the nucleus, but in fact, electrons orbit the nucleus at discrete energy levels. This made Rutherford and all the scientists who created atomic models before him look like a bitch. Do you see the pattern?
No.
Well, Bohr's model of discrete energy levels was able to explain Rydberg's formula for the hydrogen emission spectra. Hydrogen showed different wavelengths of light emitted when different energies were absorbed. Then, best of all, Schrodinger takes a stab at the model of the atom. Schrodinger introduced the idea that electrons had wave-like properties. For his model, he states that the location of an electron cannot be determined, but can only be described in terms of probability. His theory shows that electrons don't move around the nucleus in orbits, which makes Bohr and everyone before him look like a bitch. Yet again.
You can't just discredit all these people. They have hard evidence, volumes and numbers and years of experience.
Have you read the books? Have you found your own hard evidence? Then how can you trust theirs? There's also mountains of evidence disproving them.
In conclusion, Bohr, Rutherford, J.J. Thomson, and Dalton were all some of the smartest scientists of their time, and they kept being wrong sometimes.
We rest our case.
Well, that got me convinced.